Hi everybody. Good to have the semester actually going. I don't know if you all feel like me that I sort of lost a week in there, but it was a beautiful week. So I wanted to just welcome everybody, and I probably should have had the slide up there that had all of the exhibits for the semester. We have 3 exhibits. The first one we are celebrating tonight with Michael Ezban's talk, and I'll introduce him in a minute. The second exhibition is listed here. It's called Early Women of Architecture in Maryland. It was designed by one of our alumna, Sadie Dempsey, and there will be 2 events connected to that. One, a symposium on February 17th, same back time, same place. And then there will be a gallery talk and a networking event on March 3rd. In the middle of the semester, we'll have a 3rd exhibit that will be hanging in the mezzanine, and that one, I guess our theme this semester is how can you choose 3 really different themes in architecture, and that one is called Revision. It's an exhibition that a number of people actually in the school helped to put together. Matt Bell was very key, and students in his urban design class a few years ago, maybe it was last year, worked on it. And that looks at some really big projects that are being planned for Washington, D.C. So that is another one to look forward to. I would really like to thank a number of people who've helped to put these exhibitions together. Rusty Holstein, I don't know, Rusty, if you're here, I don't see you, yes, right there. And Golnar Urshad, who I think is taking care of gallery business. Rusty has really been a tremendous help in putting these exhibitions together and up in January, and I just wanted to thank you for that. And you deserve a hand for that. And Joe Largess, who I think has stepped out, also was really a big help in putting the exhibitions together this semester. So today's lecture will be followed by a reception. And I hope that you guys take the time, not just on the days we have the lectures, but on other days to walk into the gallery, to look at the exhibitions, and to find a quiet space in the school to sit, but to really take the time to look at them. They're really something special this semester. So no further ado, if I can log in, I would like to introduce our guest today. So it's really a pleasure to introduce our colleague, Michael Ezban, and thank you, Michael, for just sharing your research with us and for designing such a beautiful exhibition. It's really a gift to the school. Michael currently lectures here in the Department of Architecture and has also recently taught at Virginia Tech in the Arlington campus and at the University of Michigan. Beyond teaching, Michael's a principal at Vandergoot Ezban Studio, a research and design practice he founded with Jana Vandergoot in 2008. Michael holds a master's in landscape architecture from Harvard University and a master's in architecture from the University of Michigan. His work has been published in a variety of scholarly journals and books and exhibited in national and international venues, including the Van Allen Institute in New York City. If you haven't been there, when you're there, you should always see what they have going on, and the 2014 International Architecture Biennale in Rotterdam. Aquaculture Landscapes, which opened 2 days ago in the Kibel Gallery, is the first public exhibition of Michael's research and design work exploring the landscape architecture of the fish farm. And I would just put an aside that one of the missions of the Kibel Gallery is to celebrate new work, and we really love it when we get to be the first ones to show this work, and also to use it as a venue to create conversations about the built and natural environment and their intersections. So please also tell your friends who are not in our disciplines to come view what we have going on. This research is funded by the Charles Elliott Traveling Fellowship, the highest honor awarded by the Department of Landscape Architecture at Harvard University. Further support comes from the Isabella Stewart Gardner Museum in Boston, where Michael was in residence in 2014 as the Mader York Fellow in Landscape Studies. The exhibition, which will be open until the summer, was also partially funded by the Kibel Gallery. Please join me in welcoming Michael Ezban.
And I'll just hi everyone. Thank you so much. I'm so grateful for the chance to share my work with you today. Aquaculture Landscapes is a research project that I initiated about 3 years ago in 2013. And from this point I can see the outer edge of it about 3 years out. So I feel like I'm about in the midway in this research project. Some of the big pieces are starting to fall into place, but there's still room for things to change and to grow and evolve. And that's why I'm so happy that Brian and Ronit were able to set up these venues for me to share this work, the lecture, the exhibition, share the work with a community of designers that I respect. So I'm looking forward to your feedback and to your comments about the work. Thank you again to Brian and Ronit. Very good. The microphone is not working quite right today, and neither is my voice, so you may need to strain to hear me, and there may be a coughing fit in the future, but we'll get through all that. Aquaculture Landscapes explores the design of productive landscapes in which fish cultivation, recreation, conservation, and waste management are enmeshed. These landscapes, an ecological approach to aquaculture is enacted, which leads to progressive public-private partnerships, creative vegetative and topographic strategies, and sustainable and profitable enterprise. And you're looking at an example of just such a place. This is a fish farm and salt production landscape in the Bay of Cadiz in Spain. The water bodies that you see to the left and right of this winding dike here are called esteros. They are basins that hold water for elaborate salt evaporation channels that cover hundreds of acres. For centuries, these esteros have also been used to collect and raise sea bass, which are harvested annually and sold to local restaurants. The relatively high density of fish in these basins, which number in the hundreds in this area, attract migratory birds to this area and make this a critical bird habitat for the region. The land is owned by the state and it's leased to farmers, and a network of trails that cut through and between the farms provide public access and recreational hiking, bird watching, there's bird blinds dotted throughout, and it allows the public to observe and participate in fish and salt harvest. So this is the type of landscape that I've been researching, visiting, drawing, exploring for the last 3 years. This work, just to contextualize it a bit, is coming at a time when there is increased public interest in public literacy and sustainable food production strategies. We've seen an explosion in growth in terms of consumption of organic foods, local foods in the United States, an explosion in terms of the number of farmers markets and community-supported agriculture. And beyond the general public in the design fields, of course, there's been a resurgence of interest in urban agriculture and other modes of exploring food and its relationship to the city and urbanism. And so that's the context in which this work is coming into play. But even the most cursory survey of research within the design fields on food production and food in the city, you'll find a dearth of information about aquaculture. In fact, I found it to be a bit of a disciplinary blind spot. And so my work is an attempt to try to fill that gap a bit, to fill in the backstory and the history and come to an understanding about aquaculture and its relationship to the city, and to imagine new futures for relationships between aquaculture and urbanism. So the Bay of Cadiz is one of 12 historical and contemporary aquaculture landscapes that I've studied and visited in the last 3 years. And these case studies, along with some of the design research I'll share with you in just a few moments, They form a foundation on which to imagine and construct the aquaculture landscapes of the 21st century. So let's start with a milestone. In the very near future, for the first time in world history, the annual consumption of farmed fish will exceed that of wild-caught fish. That may happen next week, or maybe even happen today. Anybody have salmon for lunch today? Or filet, maybe put us every time. Actually, when you think about aquaculture in the broad scale, salmon is just a blip. Really, the industry is dominated by the production of carp. If you take all the fin fish, all the crustaceans, all the mollusks that are farmed in the world annually, a full 60% of that volume of fish come from China, and the vast majority of that 60% is carp that's produced in inland freshwater ponds. So speaking of inland ponds, this is another very important statistic or trend or data point in the project, which is that a full 70% of all of the fish that is farmed in the world comes from inland sources. By inland sources, I mean indoor facilities, I mean inland lakes, coastal lagoons, freshwater raceways and freshwater systems. And only 30% come from marine sources, and those are dominated by oyster production. So 70% of fish farming is really happening upland, which in my mind puts it in the purview of the designer, the landscape architect, and the architect. Now, if we look at these inland aquaculture systems, and we can start to understand them relative to their characteristics, and I created this diagram here to try to understand the poles. There is obviously a whole range of systems at play that you can find across the world, but I found it helpful to understand the extremes of conditions. And so since the mid-20th century to today, the industry is dominated by the type of farm that's described on the left here. Typically high-density monocultures produced in tank-based indoor plants. By high density, I mean raising thousands upon thousands of fish in highly constrained artificial environments. These fish are fed pellets of food. They're often administered antibiotics, because when you raise fish at densities that high, they can become a bit combative with each other. They can lose scales. The disease rate climbs quickly. And so much like the kind of problems that we run into with raising cattle and raising chickens and other sources of protein upland, when you raise fish in high density, you run into issues pretty quickly. Now, on the other side of that spectrum is the type of condition that I've become extremely interested in, which is the landscape-based fish farm. And these landscape-based fish farms these are the practices that humankind has engaged in for centuries, in some cases thousands of years. And there is a recent bit of a resurgence and a call to come back to some of the practices and to the understandings that are found in these types of environments. So they are typically polycultures, meaning they are raising more than one species. Sometimes they are raising a crop in association with a fish or an animal. The number of fish in production are kept at a relatively low density. The landscapes themselves tend to be integrated, meaning that there are avenues for public engagement, as opposed to the kind of commercial farms described on the left, where the door is closed and the public is not invited in. So in my research has kind of really been bolstered and centered around the study of 12 landscape-based fish farms. These are historical and contemporary sites around the world. And you can get a sense of their geographic spread here on this map. All the case study projects are in red, and other projects that are associated and that are of interest to the Aquaculture Landscapes Research Project are in gray and black. These are transects, 40 by 80 meter transects cut through each of the 12 case studies. And you can start to see an incredible amount of variation in terms of the types of vegetation, the spatial logics, the size of the water bodies, the type of water itself. I've been surprised at the dramatic kind of contrast. There are elements that repeat, but there are just incredibly unique moments as well. And so what I'd like to do is give you a little bit of sense of their diversity and then take you through a brief tour of 4 of those farms to give you a sense of their differences and some of their similarities actually. When you look at their timeline, you can see that some of these fish farms once existed and now do not. Some have existed for centuries. Some are relatively recent. There's a whole range. There's a lot of information packed into this slide, but when you start to understand these fish farms as multifunctional landscapes that take on issues such as flood mitigation or recreation, providing regional ecological services and wastewater and stormwater treatment. You start to look across each case study, you start to see that many of these fish farms beyond fish production have secondary and tertiary functions, making them quite robust. You can see that many feature product diversity, that is, they are polycultures. And one last interesting note is that at the very end there you can see indication for a special designation. And by that I mean that the fish, the product coming out of these farms are recognized by the state, by government as being a kind of protected product. You know how like champagne is not really champagne unless it comes from Champagne. Well, this is a similar thing. This fish tends to be so good, it tastes so great, and it's so unique to its place, to its environment, that it has special designations, special names, and it occupies a special place in the market, special protections, and there are economies built around this. I'll give you just I'll just do an end run around this a little bit and just tell you that the fact is that when you raise fish in something akin to a habitat as opposed to a tank, the fish is going to taste better. When the fish need to forage for their own food, when they exist in communities that are similar to the densities that they would naturally congregate in the wild, when they're feeding on microalgae and when they're feeding on crustaceans that they typically find in the wild, their fats are richer. The proteins have more dimension. The taste is just simply better. And it's why many of these fish farms have special relationships with high-end restaurants. Some of this stuff gets shipped internationally to upscale markets. So that's part of the special positioning of these things. The farms tend to put out less fish than your industrial-based farm, far less, frankly. But it's such a good product that there is a market for paying a premium for such good stuff. So let me just take you through a couple of these, well, 4 actually. 4 of these landscapes to give you a sense of them. First in Kibel Basin in the Czech Republic. The Kibel Basin is an 80,000 hectare wooded wetland in southern Czech Republic. It's characterized by over 500 constructed fish ponds, which were constructed between the 14th century and the 19th century. The fish farming has a pretty rich heritage in this area. Here we can see a map of the region. So the Trebon Basin is described by the red hatch, and you can see the speckling of close to 500 constructed fish farms. The diagram on the right describes the, I'm not going to pick it apart too much, but it describes the complex interrelationship between ponds. Some ponds feed into others. There's a kind of chain effect throughout them. And then if you look at this red line here, this red arrow, this is depicting what is known as the Golden Canal. It's a 45-kilometer canal constructed in the 15th century that is a kind of a linchpin bit of infrastructure that feeds and anchors many of these fish ponds. So without this, frankly, miraculous piece of infrastructure constructed centuries ago, this system would not operate as well as it does. And that is still in operation today. What is quite interesting about the landscape itself, and we zoom in closer, is you'll find that the dams that shore up these lakes, and here you start to get an example of some of the fish ponds that were constructed with these short dams. These are earthen dams that were built with relatively weak soils, and so they would, in the early stages, in the early centuries, they would collapse frequently. And so there was a planting regime that came in the 17th century, planting oak, so that the roots would strengthen these weak dams. And now these oaks have matured into these alleys of trees, and they're quite conspicuous in the landscape. You can imagine that every lake, essentially every fish pond, has its own alley, and you find these alleys and these dams have become recreational conduits. When I was there, traveling across the landscape, you find yourself walking in and out of alleys as you traverse this aquaculture landscape. It's quite beautiful. In terms of the heritage and kind of maintaining a cultural heritage, there is an annual harvest every November, and the harvest takes place with the full historical garb, and there is, it's a kind of tourists kind of flock to this event. It's a major event for the city, for the region, and carp itself is very integrated in the culture here. There's a kind of it's known that you give a carp to a family, a local family at Christmas time. I had a former student who's from the Czech Republic, and I mentioned, oh, you had a carp. And she said, yeah, I never want to see carp again. I've eaten so much carp in my life, I can't believe it. I found it to be delicious, but I guess if you grew up with it, you probably can't stand it. A second case study in Kolkata, India. This aquaculture landscape is the largest sewage-fed fish farm in the world. The city of Kolkata does not rely on conventional wastewater treatment the way that our cities do. They rely on landscape-based systems to treat and to polish their wastewater. And at the back end of that system, once the water has been decontaminated of pathogens and whatever else and polished with it, it still retains nutrients and becomes a fantastic resource for the production of fish. And so there is a kind of this secondary industry that grew up about a century ago around the wastewater treatment in Kolkata, and that has evolved into a 12,000 hectare dynamic and productive wetland in Kolkata. So this is a snippet of the landscape there, and these fish ponds, which are called locally called berry, come in all shapes and sizes. You can see that settlements array within the berry. These are tend to be owners and operators of the small and large berries that are found to the left and right of the height. Close to 10,000 people who operate, who are involved in the aquaculture landscape, live within the system. And there are markets within the system as well. Fresh markets which bring people from the city center deep into the aquaculture landscape. And so again, it's kind of creating a kind of public realm or a public environment and a space for commerce within the aquaculture landscape. A detail about it, an interesting one, is that the use of water hyacinth here to line the edges of some of the berry. It both provides shelter for fish, kind of a shaded lining around the edge, but it also reduces the amount of erosion that comes from wave action against the dikes in some of these larger areas, larger berries. A third case study here from Haning in France. This is the first recorded hatchery in Western history. It was constructed in the mid-19th century. It is known as the piscifactoire, the fish factory. It was commissioned by Napoleon III. And so this is aquaculture at a hatchery at the scale that had never before been seen. It was quite a spectacle for its time. The idea was to create an industry, or create a landscape, create buildings for the production of millions of fish eggs that could be used to restock blighted rivers in France, rivers that were newly blighted from industrial practices. They saw fish populations being decimated, and so this is a sort of a corrective action for that. And so what was fascinating to me about it was it was both a building and a landscape. So you see the plan of the space on the right. You see a small complex of buildings, but you also see a number of eccentrically shaped islands and basins, and all of this landscape here was kind of an experimental fish pond. So there was a number of different species, perch and trout and pike that were raised in these ponds, and then the actual work, the intricate work of extracting fish eggs, which was a relatively new practice at the time in the mid-19th century, was occurring within the building, and you can see the transect a bit of that relationship between inside and outside. I would have described in the designer's words, Victor Cost, who was a professor who was enlisted to kind of design this complex, how he just first described the piscifactoire. A stream of fresh water divided into narrow drains and extended into a meadow could be easily turned into a vast breeding establishment. And when this stream will have been so transformed, it should be covered with a glass roof, like a greenhouse, admitting the light, and formed of movable panes, turning round so that only air may be readily admitted when deemed necessary. So, what the result of the work was nothing like what he described. There certainly was quite a bit of rearranging of streams and production of subterranean aqueducts and whatever else. It was an incredible feat of hydrologic engineering, but it didn't quite reach this kind of poetic notion of sheets of glass suspended over streams. But what I loved about his original intention is that the hatchery was rooted in the landscape. It was inseparable from the landscape. So as I mentioned, the scale of this operation was unseen at the time. So it attracted the public, it attracted special dignitaries, and there were public itineraries that would run through the experimental fish farms. And the rather handsome buildings of the fish factory itself had public viewing galleries and observation decks. So it really was, it brought 19th century agri-tourists to a pretty special place in the world. And the last case study, this one starts to blow out the scale of the case studies, is in the Pearl River Delta in China. And this satellite image gives you a sense of the fabric of this intense and pervasive aquaculture landscape. So what you're looking at is fish ponds and farmed dikes in between each of the fish ponds, and you start to get a sense of settlement an urbanism that conforms to the fish ponds here. When you to look more closely at this system, which is called the dike pond system, it's really a constructed ecology. What you have are extremely deep fish ponds, which are fish ponds typically across the world tend to be around 1 meter or 2 meters deep. These are double that. And the farmers here were savvy enough to understand that different species of carp will occupy different strata within the fish pond. So there are bottom dwellers, there are folks that hang out at the top, and so you can get 6, 7, even 8 sometimes species coexisting, and so you can feed different markets and diversify your product. Now, the real genius of the system is that it was understood that the kind of the fecal matter of the fish falling and drifting down to the bottom of the fish pond creates an extremely rich layer of soils that can be scooped out and applied to farming on the dikes. This is just, you couldn't ask for better fertilizer, essentially. And so there's this really, there's kind of circular relationship between the pond and the dike. I'll give you the most famous example, which is the mulberry iteration of the dike pond system. So these are mulberry trees grown not for fruit, but for their leaves, because the leaves would feed silkworm. And so silk, for many centuries in China, demanded a huge price. It was an extremely lucrative crop. And so it was also found that the silkworm droppings were perfect fish food. And so the droppings from the silkworms would come back to the pond, the droppings of the fish would collect in the soil, come back to fertilize the mulberry leaves feed the silkworm, and on and on and on. Just an incredible relationship between pond and land. And as I had mentioned before, incredibly pervasive. So this is a glimpse of the Pearl River Delta. This is currently the most rapidly urbanizing area in the world. And this drawing maps the urbanization, which you can read in light gray, at about the mid-1980s, a moment when the dike pond system was at its height. Now, by today, the amount of urbanization in this area has doubled. And the fish farming has actually collapsed with the liberalization of the economy in China in the 90s. But what's left is this. This is the ground condition of all of that area in red hatch. And so there's a question of how this rapid expansion of urbanism engages the fish pond. In some cases, there's an erasure of the fish pond altogether, and in some cases, you find creative accommodation of this ground plane. But to me, the fish pond here is really an increment from urbanism, in the same way that you might think of the city block as an increment of the city in western cities. So just from that brief tour through 3-4 of the farms, you start to get a sense of variation in spatial logics, variation in scale, variation in product. What you'll also probably notice is that I'm not mentioning any designers. There are no landscape architects or architects involved in any of these 12 case studies. And it's not to say that there have not been in history. In a moment, I'll show you a couple of designed aquaculture landscapes. Well, we certainly know that landscape architects and architects have been involved in this discourse of productive landscapes and the design of them, the meaning of them, really. We can look at A.J. Downing and Stephen Switzer and their work in the 18th century on the ferme ornée, or the ornamented farm, right? So this is an attempt to consider the productive landscape, but also to bring in questions of aesthetics and views and kind of sequences and narratives. We can look at Frank Lloyd Wright's proposal for Broadacre City. His subdivision of land to 1 acre plots, which were meant to be essentially subsistence plots. So this is a kind of urbanism based on crops and agriculture. And finally, look at a more contemporary example like Han Zhang-Yu's work at Shenyang University with the rice paddy campus, where a kind of civic plaza scale space is kind of activated by the activity of rice harvest, and that's the kind of central mall at a university. So we see here a course, a rich history of designers engaged with productive landscapes, but again, a bit of a dearth of attention to aquaculture itself. Now, we can look at a couple of examples here. The piscina, which was a fish pond, a typology that was constructed largely during the era of the Roman Republic, and found, I think there are at least 56 examples within the central Italian peninsula. This is one rather dramatic example at the Grotto of Tiberius in Sperlonga in Italy. So this is a piscina, a fish pond, which is kind of an ornamental and productive fish pond that's tucked into a naturally occurring grotto at the seaside here. The villa of Tiberius would have been just upland, so this is very much connected to a seaside villa. In fact, all of the piscina were. They were really fish ponds for the elites. But you can see here with this diagram, this drawing, there was a careful attention paid to the distribution of statuary within the fish pond. This is a glimpse here into the grotto, and as if you were seated at the piscina itself. In fact, you would be seated here and looking into the grotto. And this area here was called a triclinium. This is shown as a ruin, but there would have been a covered pavilion here for dining. So that moment right there, centered on the grotto, in the middle of the piscina, was a kind of privileged view to an elaborate story, mythological story about gods and the sea depicted in the statuary. So here we see a kind of enmeshing of mythology and narrative and fish production and consumption. We can fast forward 1,000 years or more and start looking at the Baroque estates in England. And we see a fish pond here at Durham Park. These fish ponds would have been known as stew ponds at the time. They were both ornamental and productive. And they joined deer parks, dovecotes, duck decoys, rabbit warrens, and other modes of protein production on these grand estates. And finally, if we look at a very contemporary example of a designer engaged in landscape, in aquaculture landscapes, we can look at a quite famous example known as oyster texture by Kate Orff and Skate. Many of you have probably seen this project. I myself, I don't believe I've ever seen a speculative design project get so kind of pervasively displayed and seen within the public realm. Kate Orff did a TED Talk. She was one of Time's most influential people. You saw this thing on CNN. Oyster texture was almost inescapable a few years ago. But it's a wonderful project. It's certainly one of the best examples of a speculative aquaculture landscape. So what we're seeing here is we're on the waterfront of Queens, the waterfront of Brooklyn here, and we can see a landscape architecture here of berms and a series of kind of low pylons. And what these pylons are they're armatures that are from which are suspended fuzzy rope. And the fuzzy rope is intended to become a substrate for oyster. So this is an attempt to build the habitat on which the historic oyster populations which collapsed in the river might start to rebuild. But smartly, Kadorf and Scape were looking at the secondary and tertiary uses of such a landscape and talking about how a field of fuzzy road and sediment accumulation and berms might start to play into an urban strategy of resisting sea level rise and attenuating storm surges and storm waves. So here you see the full array of the system here lining adjacent to Sunset Park and Red Hook and all the way up to Governor's Island. So this work was commissioned by the Museum of Modern Art in 2008 when they commissioned several architects to take a look at the waterfront. And this, in my mind, was one of the most inventive and interesting examples that came from that study. So in the last part of this project, in the last part of this talk, really, what I'd like to do is actually share my own museum commissioned design research, which I produced while I was a fellow at the Isabella Stewart Garden Museum in Boston. And it's known as quality fishery. And this is an aquaculture landscape. It entangles trout cultivation, greenhouse agriculture, wetland habitat, and infrastructure for angling and other recreation pursuits. It's sited in central Massachusetts. And the project examines the aquaculture technology of aquaponics in an effort to tie a proposed fish farm to local and regional economies and ecologies. Aquaponics, just briefly, tends to be a small or mid-scale practice where the residue from fish rearing, the kind of wastewater, the nutrient-rich wastewater, is used as a fertilizer for hydroponic vegetable production. And the wastewater that comes from that can be cycled back to fish. So it's a relatively closed-loop system that has been explored, as I said, in small and mid-sized farms. It's a tested technology where it seems to work great. And there's probably about 1,000 of these sized farms in operation in the United States. And what this work was doing was starting to question the technology and question what might happen if we think about expanding that technology, scaling it up. Are there ecological or economic benefits, what are the spatial ramifications for expanding this thing? So if we start to think about shifting from aquariums to arrays of raceways for trout production, or if we move from hydroponic trays to a landscape of greenhouses, or if we move from biofiltration buckets to treatment wetland. Are there opportunities that come for integrating recreation, integrating public engagement, expanding economies when we make the system more robust, when we expand it and blow it up? So the context in which I'm exploring this stuff is in central Massachusetts, as I mentioned. What you're looking at here, the large water body, is Quabbin Reservoir. This was a reservoir that was constructed in the 1930s to serve as Boston's main drinking water reservoir. There's a massive constructed freshwater lake. Boston is, from this map, is 60 miles to the east, so it's quite distant. So the water travels to Boston via surface and subsurface aqueducts. But you can see here, there is a culture, there's an economy here in central Massachusetts dominated by the production of rainbow trout. So we see examples of both private farms and state-owned and even national scale hatcheries and fish farms. The context of the project also exists within a burgeoning agritourism industry. So every orange dot on the screen represents a farm that opens its doors to the public, either in kind of pick your own orchard situations or whatever else. But these are farms that are realized that there is revenue to be had by opening their doors to the public and inviting folks from the city and from the surrounding area to have adventures with food on their farm. It's also important to note that within this context, there is the greenhouse production of vegetables is kind of a dominant condition in terms of the agriculture economy. And the last important contextual bit for this project was that starting to understand and locate tailwaters. And a tailwater is a very interesting condition. A tailwater is essentially a river that is fed by a reservoir. So there are tailwaters at every one of these reservoirs that is identified on this site map here. Kibel Reservoir is by far the largest, but there are around 28 or 29 in central Massachusetts. And tailwater has a particularly profound effect on fishing and angling, specifically for trout. So just to give you an example, here's an image, a cross-section of a reservoir with a dam and a river that's fed by a reservoir. And so one of the things you'll notice is that the river downstream of a reservoir tends to be fed by water that is at the bottom of the reservoir, meaning it is nutrient rich, but also colder than water found near the top or water that might be found in a regular freestone stream. So the effect of that, of drawing water from the bottom of a reservoir, is that you have it has a moderating effect on water temperature, meaning that there aren't extremes. It doesn't get extremely cold. It doesn't get extremely hot. It stays right around, in central Massachusetts, right around 38 or 39 degrees. When you touch it, it's cold as hell, but it's perfect for trout. It's terrible for bass, warm-loving fish. And that's why every time a tailwater is constructed by creating a reservoir, the bass quickly flee downstream, and the trout flock and flourish. And then the anglers come, because tailwaters are known to be, nationally, some of the best trout fishing that you can find, period. And the Swift River, in fact, which you can see here, trailing off from the base of the Kibel Reservoir, is known to be one of the best fishing spots in Massachusetts. So in my mind, it was an interesting and important area to consider the intersection of angling and aquaculture. Because here we have a water source, a pristine water source. We have a culture of fish farming, and we have an economy of agricultural production. So all of these things, all these synergies seem to be aligning here. And so that was the basis of kind of citing this thing where I did. So here's the site plan of the existing conditions. The Swift River emanating from the base of the Kibel Reservoir, and some of the existing conditions there. And then this is a site plan of the proposed Kibel fishery. So this is a 2-mile-long, somewhat linear aquaculture landscape. It has moments of high intensity, and it has moments where the fishery is quite thin, almost as thin as a simple trail. There are 4 zones really that characterize the place, and that I'll describe to you through some drawings and photos. The pump house market, the hydro crop, the aqueduct tailwater trail, and the angling camp. And these 4 zones are quite different in terms of function, but they also start to borrow a kind of formal vocabulary of lines and trails and low slung walls. So there's a kind of connection between all these spaces. There's also a kind of material hydrological exchange that's happening in between all of these spaces. So these aren't independent nodes, but they're all quite interrelated. And so one of the benefits of starting to expand the aquaponic system to an aquaponic landscape was the ability to start to allow for vermiculture or worm building, and to start to allow opportunities for integrating an angling camp, and to start to create opportunities for bird habitat, which would bring ecotourists and other bits of other forms of revenue, diversify revenue streams at this place. So I'll just briefly touch on the 4 areas. So the pump house market is intended to be a moment of high activity at the site. It's a point of arrival where there's a seasonal market, there's a visitor center, a bait shop, and also a kind of a cistern that holds some of the water that's then pumped through the system for farming. And this is a section perspective through that moment of introduction to the site. Blooming beyond this area is the really quite surreal line of the Windsor Dam. So the Windsor Dam is a half-mile long earthen dam that's holding back billions of gallons of water of the reservoir. And when you see that straight line of grass meeting the sky, it's quite a surreal moment. So some of the straight lines and geometries in the foreground here of the landscape architecture are starting to echo that quite astonishing line in the landscape. The hydro crop, which is the main area of production, is just beyond the house market. And so this is truly the area where trout production and hydroponic vegetable growth is occurring within these glass-lined greenhouses. You start to see these elements start to pull away, and a filtration and integration of tree lines and trails. And this is a cut through that kind of corrugated landscape. So you start to get a sense of scale relative to trail, building, and trout raceway. As I mentioned before, there are moments in the project that are quite thin. The Aqueduct Tailwater Trail, where there are low rock walls that start to bridge the land and start to extend into the Swift River. And these rock walls that start to scour the bottom of the river and form fish habitat are also found edging the trail above and marking a subsurface trail that takes water to Boston. And so here we see a kind of celebration of a pipe underground that might not be recognized at all, a kind of marking of that and a creation of a recreational conduit along that line. And then finally, trying to address the relative lack of spaces for large social gatherings or semi-large social gatherings along the Swift River. This is the angling camp. And so again, it's starting to borrow some of the language of rock walls that form habitat in the river, extending upland, the creation of small pockets for campgrounds and gatherings. And the result of that language is the creation of spaces like this one, where you might launch a kayak into the Swift River. There's space for a bonfire, space for a father to talk to his son about technique and bait. And it's a kind of crossroads, a bit of a meeting grounds between folks who are engaging in passive recreation and anglers. So, one of the benefits of this type of water that's being drawn from the reservoir is that it is the perfect temperature for aquaculture and the perfect temperature for angling year-round. And so, some of these areas in the landscape, some of the different zones, the market, the crops, the camps, they take on different intensities throughout the year. So things become a little bit more dormant in the wintertime, but not fully dormant. There are other moments and nodes and activities that allow for these different spaces and places to be populated at different intensities over the year. And so, a parting shot here, the aerial view to the hydro crop, to the Windsor Dam, to the reservoir beyond. And then a nod above to the idea that some of the ideas and the logics here that are being tested at Aquaculture Reservoir, the Swift River, might be applicable in other tailwaters, some of the other 29 tailwaters. This is certainly the largest, but many of the systems here that are being tested are adaptive relative to their size. So there could be smaller iterations of this type of farm, this type of aquaculture that populate central Massachusetts on public land and that adorn some of these other tailwater landscapes. So just in this 45 minutes here, I've walked you through 4, maybe 5 or 6 of the landscapes that are kind of fully elaborated within the exhibition beyond. So there are 14 landscapes that are studied and drawn and in detail that you can see in the exhibition. And if any of this is of interest to you, I invite you to check out the exhibition. It's going to be up until summer. And again, I want to thank you for your time, and I'm happy to take any questions.
You said that you're just beginning to kind of get a grasp of the project, and you see the end of it being maybe 3 years out, and you see there.
What do I see there? I see a book. I do see a book, actually. But yeah, no, what I see there is, I think, more work in discerning the particular strategies that come from these landscapes. I think what I've done so far is I've identified these places, and I've started to draw some of these interesting topographic and vegetative strategies. What's less clear to me now, and what I hope to become more clear as I start to diagram this and explore this, is how applicable some of these examples are. Are they geographically constrained? Are they truly amazing places because they have conformed to the unique conditions of the place, of the temperate zone, of the geology, of the culture? Or are there elements that can transcend place? And I've got an inkling of that answer, and the answer is that yes, that there are. I have seen some interesting things. In fact, you guys might notice that there were 2 places in the Czech Republic and in China that were producing carp, right? Freshwater carp, some of the same species, right? You know, the landscapes and the cultures are quite different, and yet there is an understanding of holding fresh water, creating habitat, and producing high volume of fish. But at radically different scales with radically different spatial logics in play. So that's just an example of, I think I need to start tying threads between these places a little bit more. Thanks for that question. Yeah.
So you spoke about the difference between a monoculture and a polyculture, about the indoor versus the outdoor systems.
Yeah.
But I'm wondering, in the outdoor systems, when you have one main type of fish,
Yeah.
does it get, are the nutrients, does it get worn out, basically? Do you have to, like, rotate crops as you would on the land?
Mm-hmm.
Or, when you say that it's a polyculture, when you have one dominant type of fish, does that hurt the environment over the long run? Or in some of these longer running ponds, have you found that there's other fish that they introduce to kind of balance it out?
Yes.
Even if they're not crop fish, so to speak? Or...
Yes. The answer is yes. That the success of a lot of these landscape-based farms is that they allow these landscapes to operate as habitat. They are constructed to perform like habitat, and so they do allow for a diversity of species, but some of the fish might not be for market. they might end up just kind of being swept in with the tide in more coastal fish farm conditions, like the Asteros, actually. The very first slide in Cadiz, they're really trying to pull out 2-year-old sea bass that are ready for market. And in fact, when these guys are harvesting the fish, if they pull out one that's too young, they throw it back, because it makes sense to keep it in the Estero for longer to fully develop. But along with that scoop, they're probably, I know they're pulling out sea bream, they're probably pulling out eel as well, and other things that they're not necessarily going to bring to market, but things that make this place an ecosystem, that make it healthy. Now, one little side note that you mentioned there, do these places have to get cleaned out? Do they get worn out, I think you said? The answer is yes, they can definitely become stagnant. And the definition of a fish pond actually is, what separates it from a lake really, is it is a water body that can be drained and refilled. And so yes, in most of these conditions they drain annually. There's a drawdown, there's a cleaning out of the muck. Sometimes they're putting down a layer of lime or something for this pathogen, and then there's a refilling and a restocking. So it's a really kind of, there's definitely a kind of mechanical process, which is what's fascinating to me about it, that it's not just a naturally formed place in the world that happens to be good for fishing. It truly is a constructed habitat that's operated and maintained to the nth degree, really, to be successful. That's a great question, thanks. Yeah.
Do you encounter any obstacles or threats to the systems that are challenges in really like food and species?
Oh, absolutely. Yeah. Oh, yeah.
Want to
Almost.
repeat the question?
Yeah. Well, the question was, are there obstacles such as contamination or pollution that threaten the viability of these systems? And yes, in almost every case, these landscapes are up against the general kind of environmental degradation that we see everywhere as a cause of industrial production. So everything from contaminants in the water, well, to agricultural pollutants, like the overuse of chemical fertilizer, which washes into water and overstimulates the wrong kind of growth in the water, creates dead zones. Those are all hazards, to be sure. Kolkata, the sewage bed aquaculture, has one of the most interesting systems in one way, because they have set up, strategically they're set up with a kind of buffer, right? Because the farming is downstream of their landscape-based wastewater management, right? So the wastewater management, water from the city, runoff, stuff from toilets, everything is coming, and then it's being processed, and then it's coming to the fish farm. So there's relatively little input of contaminated water from other sources. So the system is actually quite ingenious because it's got its natural filtration in place. They're having other issues in terms of siltation and sedimentation. But there are other examples of places that have a small bit of landscape-based filtration ahead of the actual fish production, and that's a means of counteracting that. But it's certainly a hazard, and it's one of the reasons that indoor facilities have really kind of blown up in recent years, because they can just recirculate their kind of isolated, pristine water within a kind of closed system. My view for that is just in closing down the system so much, I feel they're resisting the need and the opportunity to engage the public in a food landscape.
Okay, why don't we take one last question, Jen, and then we'll go solve it.
Yeah, so when you were at all these different sites, besides drawing, how did you go about collecting all this information for most of your time when you were visiting these places?
Well, there was, most of my time is spent walking I've walked miles and miles in wetlands. In fact, I keep finding myself in like 10 miles deep into a wetland thinking, well, here I am again. Another productive wetland on the other side of the world. But I do set up meetings with like the chief engineers or the head biologists of these places who are often quite generous with their time. Because obviously like many of these places have been written about in the natural sciences, and you can go to McKeldin, as I often do, and research these places and find great data sets about them and great studies, and so you can understand the workings of it. But I, of course, am always an advocate of both kind of talking to the people who actually work there, who are actually, liming the soils, or who are actually working with the oxygenation levels of the water, who have a working knowledge of the ecosystem that they're trying to create there. Those types of conversations are invaluable. And what is also invaluable, I think, both for myself, for students, and for anyone, is really to walk the landscape, or to visit the building, or for your impression and your instinct to come into play about the place, that when you return from a site visit, any site visit, you sit down, and what starts to come into play on your table there is information you've received from books, from conversation, but also your own instinct as an individual and as a designer. And all of that starts to come out in your in the drawings that you start to make and investigate the place.
That's a wonderful place to end. I was remiss in not thanking the many students who helped put up the exhibition by volunteering their time, so thank you as well. And Michael, thank you for such a really rich and